Hello, community! Let's talk about RAG, and I mean RAG today, May 21st, 2025. Let's explain it. Well, of course, we could start here immediately with a chain-based knowledge graph RAG methodology, or we go with a multi-agent RAG with a semantic partitioning of linked information for type-specialized split RAG. But you know what? It is amazing. In the last 2 days, my AI deep research detected here 58 new AI research preprint. This means new RAG implementation in 2 days. Those are the 2 days, and we will have a look at about 1 or 2 dozens of them. But let's start, because I was also asked, hey, if I start with RAG today, can you explain it? Well, of course. I'm so glad that you asked. RAG explained. Now, in the good old times of artificial intelligence, we only had a single monolithic large language model to do both here, the search and the generate and the augmentation. And this is here what we call RAG in the good old times when humanity and AI just invented here the wheel and we were about its Stone Age. No? And then we found out, like, for example, here with OpenAI's proprietary O3 Pro, we have a very knowledgeable expert LLM who can answer question well if given the right information from external data sources. And we developed quite a lot of new function calling. We have in our MCP, A2A, model context protocols, agents-to-agent protocols. But it's not really a good performance. So what we did, we said, okay, but this LLM here, this expert LLM, doesn't really know how to find information efficiently. Because maybe it doesn't compose here the complexity in an efficient way, maybe it has no feedback loop given here a particular search engine, and there are a lot of other reasons. So naturally what we did, we wanted to train here a separate LLM, we call it now a search or a searcher LLM, whose only job and absolutely now trained to find the best possible documents for the other LLM. So we have now a specific tool that this system is optimized for. And let's say it's a search engine and go with the most famous one. Let's do with Google. So you see, suddenly we had 2 or multiple LLMs, and you know what's happening now in the last month. We went from an LLM to an agent. Now we have multiple agents. We have multi-agent system training. So we are now, if you want, now in the Renaissance here 500 years before today. As you see, it's not anymore RAG, but let's go, because it's such a beautiful old term, no RAG. So the retriever is not anymore a retriever, if you want to call it, yeah? Because now we have a specifically trained, a dedicated AI agent, maybe even a cluster of AI agent, more about this later, with some excellent tool use capabilities. We have a self-learning agent for those tool users that is extensively trained on a specific search engine. So this is a highly dedicated expert system that is really improving the quality of our complete RAG system. But you see, from the good old retriever days, when we had, I don't know, LangChain or something like this is all gone. This is not anymore there, because now we have a completely different architecture of it. But RAG, the term in itself, is still there for external data for an artificial intelligence. There was one paper in 2025 that changed everything, and this was here our DeepSeek R1. And I don't know if you noticed this, especially the R1.0 model, because this showed us here in the community that even rule-based, outcome-driven rewards can train strong reasoning agents. And this kicked off something amazing. Let me show you this paper. I don't know if you're familiar, this is University of Illinois and Korea University, the deep retrieval. So the real search engines and retrieval with LLMs via reinforcement learning. This was quite an influential paper because it had a reinforcement learning approach to train our very dedicated LLMs for a very generation through not human annotated, but trial and error without supervised data. This was amazing. You just tell a system, hey, self-optimize yourself. And of course, we had to have success factors. We call it here retrieval metrics here. And if you know about reinforcement learning, we have there another term. We call it a reward function or reward system. If we define now this metric, these rewards, our system generated queries that really maximize here the retrieval performance. Great. So this was here 2025, absolutely amazing. let's have here a view abstraction here. So we have here the user query. Now, this is the input. Now, this is great, but a user query is not really precise. It's not to the point. It's not optimized for a specific search engine. It's not optimized here for the format maybe you have in your proprietary database in your company, or not optimized for a particular NoSQL database. So if you go to the internet, you have to have a multitude of different query structures. So what do? You have here an LLM and you do the reasoning and said, hey, let's augment now this human query. Yeah? So you have a thinking process, and then you say, okay, here I have now optimized the query. You have an augmented query, or you have multiple augmented query that you have now multiple parallel augmented query that are now the real, if you want, input to the retrieval to the search engine. Let's say it's Google, or you have a SQL, NoSQL, whatever you like. Never mind. And then you had somewhere the true context, and you retrieved here from the true context the retrieved context given here your particular augmented query, and you have a retrieval reward computation. It is simply you check, hey, given here my augmented query, is this really the content that would answer this? And you have also different reward function, like a final reward function includes here a format reward, not just a retrieval reward. And you can calculate this and you see, hey, some of those things are really working great, and some of have no generated information at all. So you update here with the specific parameter now your LLM. So you see, we have now, if you want, a looping process to optimize here the LLM specifically in real time for this particular search engine or for your particular SQL, whatever you have. So we have here a dedicated optimization problem in front of us. So you see the RAG here, the retriever is not there anymore. The augmentation from a monolithic LLM is not anymore there, because what we have now is a reinforcement learning approach that trains now this, let's say we know it's an agent, or let's say it's a large language model, for the query generation itself. And this is really great, and they did some tests on the performance, on the benchmark, and they tell us here it outperforms here the leading methods on literature search. If you are science, you know literature search with 65%, and SOTA is 24% recall for publication search. So this is a big jump. So this is something where we say, okay, if we let the system train to optimize itself, not the human search query, but hey, let it search and let it optimize itself, this is where AI shines. If you want to see this, by the way, yeah, I'm always asked about code. Here we have the deep retrieval, here the GitHub repo. Everything is available for you there. However, if we now go a step further, do you notice that there is something not really optimal, not really perfect? Because the metrics that we use, and it's recall and a non-normalized discounted cumulative gain, you see more in the papers that I showed you, they are disconnected now for the downstream answer quality. So the real answer, the end answer for the human query is not integrated here in the performance benchmark. And you might say, maybe this is something that I want, yeah? Because the end product, if you want, is the quality of the final answer given here by the artificial intelligence. So we had a new publication. This is here also University of Illinois, University of Massachusetts, and Google Cloud AI Research, Search R1. So you see, what DeepSeek and R1 particular ignited is much beyond what you maybe thought, because it has a massive impact here on reinforcement learning and on RAG system. This paper here was beautiful. Search R1 trained here a single model, a language model, to jointly retrieve and generate here via reinforcement learning, using now here as a reward function here the exact match. While this approach now improved further the answer accuracy, the tight entanglement between the search and the generation makes it difficult to isolate here some real genuine retrieval improvements. So, and they did this, by the way, for the PPO, for the classical PPO with a search engine, and for the group relative policy optimization with a search engine. And you remember here, we do not have here the value LLM we go without. We have a relative group specific Of course, we have a Kullback-Leibler divergence, but what they did, and you have here the advantage function, beautiful, we talked about this here for the group computation. And of course, during the rollout, LLMs can conduct multi-turn interaction with the search engine. So you don't have here a single turn, but you go now in multi-turn. So this is really an optimization that we're looking for. And this was really a very important paper with some great performance improvements, because the LLM learns now, and later the agent, to autonomously generate multiple search queries during the step-by-step reasoning with the real-time retrieval. So you learn on the real available data volume, on the data quality of this particular moment in time. And you don't have to reference some data quality, maybe a month back, maybe a week back, or whatever. So you have a real-time optimization problem that you can solve. Benchmark Search R1 improved the performance by 41% if you go with a Q1 2.57 billion free trainable parameter, and at least if you go with a 3B, 20% over the RAG baseline under the same settings. So real impressive performance gains here. So great. Yeah, if you want to read this in more details, I have given you the text. We have here simply the search here. We have the designated call token, search and end of search. Then retrieve the information. We have the information and end of information, special tokens and the answer tokens. Have a look at this. This is a beautiful GitHub Search R1, and for me it serves another purpose, like an open solution here to OpenAI Deep Research, enabling here research and development in a tool-augmented LLM reasoning. If you have a look at this, you immediately notice here how is it working, on what is it working, and it is working here. And I have to do a video on this, on a volcano engine reinforcement learning for LLMs. This seems to really be now the new standard. It's a production-ready reinforcement learning training library for LLMs. And more or less every single AI publication I've seen in the last month here, especially here from Asia, Southeast Asia and China and those expert locations, they run here with our volcano engine reinforcement learning. If you want to know, I'm planning a video on hybrid flow now for more than 2 weeks already, but yeah, I have to do it somehow. If you want, this is here the open version of the hybrid flow paper, but this is a little bit more challenging paper, so I have to do a specific video on this. But just if you want to know, if you want to run this operational, get yourself familiar at least here with the volcano engine, or if you're really into the theoretical deep dive with hybrid flow, I have to do a video on this. So what we achieved, LLMs learn through direct trial and error. Great. Because we have a real-time data connection, we have real-time data, and we have a real to-the-minute training of the system. With the real data, we have no synthetic data, we have no simulation. We are not referring to data that are maybe months old. You find these models on Hugging Face. Great. However, if you're really into the details, and if you say, hey, I am here just to make it perfect, yeah? You notice that Search R1 trains here a single language model to jointly retrieve and generate. Using here, of course, the exact match here as the reward function, but as I told you, these entangles here, search and generation. It requires here the full model tuning, and here, particularly this metric is a little bit brittle, so not the optimal one. So we have to go a step further. Just a summary, if you're not really familiar, again, RAG, reinforcement learning, PPO, search agent, just for you to summarize. Now let's come to a new paper. And now we say, listen, I have an idea. What about you reward now the assistant LLM or the agent based on how much better the expert LLM or agent performs with the information the assistant agent provides? You compare how much the expert would have performed with the basic naive RAG, and you develop a complete new metric, and you call it here the gain beyond the naive RAG system, and it's called GBR. Okay, so what we have, think about this. We have now at least 2 or 3 agents or LLM, expert LLM, that are really trained on a particular domain for a really downstream task. We have this one. And of course, sometimes your OpenAI, you have not access to the model. You can't fine-tune it. You can't ORL. You can do nothing. This is a proprietary model and you have to pay them that they do it for you. So this is not perfect. But you say, no problem, because I have other agents here in my cluster. No? And if you now optimize here the search LLM, this will do a lot of the work for you and you can get some significant performance increases. So let's have a look at this. So by focusing now the learning signal, if you want, directly on the value added by the complete search process to a now fixed generator like an OpenAI model that I cannot have access to the weights, we have now a new method. It's called S3. And this efficiently trains now a highly effective search LLM or search agent for RAG with our fixed generator LLM. I achieve a modularity. This means that the trained searcher LLM can serve now any capable generator LLM. So if you go now with, I don't know, OpenAI, if you go with Anthropic, with Claude, whatever, it doesn't matter because the work is done here on the interface, here on the optimization of the compound, but focusing on the search agent. Now, it decouples the search agent or multiple search agent, depending on the complexity of your system, from the generation LLM, from OpenAI O3 Pro or whatever you have. Then it optimizes here the search agent retrieval strategy based on its direct impact on the downstream generation task performance. It is therefore compatible with any frozen or black box LLM from OpenAI. And we achieve a real strong performance gain with significant, and this is now amazing, with less training data than all our other based reinforcement learning based RAG methodologies. This is nice. Yeah, S3 stands for Optimized Search, Select and Serve. It's a lightweight model agnostic framework that decouples here the search agent from the generator agent. So it trains here a searcher LLM using reinforcement learning, classical, what we learned from the DeepSeek R1 model, with a novel reward signal functionality called Gain Beyond RAG. Now, of course, you immediately understand that it is not just a classical naive RAG, no, but you can have a graph RAG, you can have a split RAG, whatever you have currently operational in your system, you go now and say, hey, this is the worst possible case. And you look for a gain beyond this, what you have implemented, and you optimize it against your current best benchmark. I think it's such a beautiful idea. Look, this is here the publication. Yes, I know it's not from yesterday, but the day before yesterday, May 20, but never mind. S3, University of Illinois and Amazon, you don't need that much data to train a search agent via reinforcement learning. And if you look now at the performance data, you see here the average score, so up is better. So S3 here, the red one, is real nice in the general domain RAG, or if we go here with medical domain RAG, you hear one of the best performance indicator here. Plus you have here on the x-axis here the amount of training data that you need, from 2.4K to 170K. But look where S3 is located here. This is beautiful. So you have a little bit more of this search R1 methodology of a 7B free trainable parameter model, but with much less training data. This means it costs much less time, costs less money, and you have the same performance. This is really nice. For medical, it's a little bit special. You see here, if you have your deep retrieval, here you are a little bit better here in the quality, but the amount of training data that you need is simply amazing. They tell us here it's about, compared to baseline, the other system need about 70 times more data. And this S3 consistently delivers strong downstream performance across 6 general Q&A and 5 medical Q&A benchmarks. So you see we have, and this is also the way I build up this video till now, We have here the classical RAG, the retrieve and the generation, and then we have here the pre-reinforcement, the pre-DeepSeek RL0 method here, where we had a distillation, a supervised fine-tuning. This is what we call the self-RAG. I have a particular video on self-RAG. It's more than a year old. And then with DeepSeek Reinforcement Learning 0, we have now here all this deep retrieval, search R1, and now the brand new S3, the metric gained beyond the classical RAG as a reward signal coming back in the optimization loop for training your model. Real nice. So just to make sure here from the original paper you have here this visualization, you see this searcher S3 ends really here. It has here a clear metric and it does nothing to the generator. The OpenAI model that does now here, if you want here, the whatever, because this is frozen. We have no access to the OpenAI proprietary model. So therefore, to make it here so clever, this modular system here of the latest RAG implementation, you can use any generator LLM, open source, proprietary, whatever, big, small, compressed, quantized, as you like, and you will get a good performance. And now the main question that remains for me is, but wait, if I use here an end-to-end approach, like in Search R1, okay, I have the same model, but I have a complete system optimization. If I go now only with a search optimization, would I be at least as powerful in my performance as would have a complete generation accuracy metric defined for the performance increase? So how much better is this gain beyond RAG system now if you go here with naive RAGs? Where are the data? Yeah, I just want to show you this here, this cycle. As I told you, data are coming in a second, just give me a sec. This gain beyond RAG, it's so beautiful because it's a relative metric that we have here, our optimization. Eh? You have your human question and then you have your search agent. Let's call it the searcher. Great. The searcher has now access via tool use to, let's say, the Google search engine somewhere or your particular search engine, never mind. So we have now documents coming back, doc 1, doc 2, whatever, we have information coming back as a feedback from our, let's say, internet query. Eh? And then we have the doc IDs and then we have here the planning and we say, hey, is the search complete? Have we achieved here what we set out to do? Our metric, our parameter, really, do we have now achieved what we wanted? If it's a no, you have a query generation and you start here the complete loop all over again. If we have everything that we need, great. So all important docs here from the S3 model, great. What we have now, yes, of course, we can then go and hand over the results here to a generator LLM that is frozen like OpenAI. But we also can compute now the particular reward function because we want to be better than anything else. Eh? And here, if you see here, this is just here where you go here with your DS3 minus here your D naive RAG coefficient. You can go here with any other RAG system that you want. You optimize the system against a very high performance benchmark and you let just the system self-train itself to become better as you already, whatever you already have. And I think this is an absolute fascinating aspect here. And it's really a gain beyond whatever RAG system you have implemented, reward function, and you have a reinforcement learning training with this particular metric. Because this now updates here the search agent and for your particular query and for your particular search engine, for your domain-specific data, for your complexity level that you are searching, you can now run this. Because maybe if you have a real simple search, the naive RAG will do the job. You don't need to do any crazy stuff. Yeah? But if you have some real complex problems, then this system will optimize itself. And I think this is just beautiful. The search element interacts with a search engine iteratively. It generates queries, retrieves now the documents, like here, selects a subset of useful evidence, great, and decides whether to continue searching, yes or no. And this, as I told you here, this is so beautiful. This effectively filters out questions that are solvable by a naive RAG, allowing it here to focus really here on the harder queries where improved retrieval is essential for generation success. What a beautiful thing. But you know what? If you look now at the real code implementation, you see, and this is a screenshot here from their publication, they still go with PPO. And I understand it regarding now the stability of the system. But hey, come on, PPO 2017? I mean, just look at my videos here. I said, here, forget here PPO, we have DPO, and then we had GRPO, and here the videos from GRPO to DAPO to VAPO. Or you say, hey, what about here complete new generative reward models from DeepSeek, where we have a self-principle critique tuning. Or if you want to go with reinforcement learning, go here with zero reinforcement learning and off-policy Luffy, where I showed you here complete new methodologies. Because, you remember, this is more than a year old. Yeah? We had here, my God, Anthropic. Yeah? You remember? Prompt caching here, re-ranking methodologies. This is really Stone Age. And then we had from Oxford here Agentic RAR, the update. And then we had GraphRag and LightRag and PathRag. And we went further to multi-agent G-RAGs with knowledge graph and agent here for our RAG system. And then we had here a demo with GPT 4.1, where I showed you the security breach with a chain of defensive sort RAG system. So it is amazing what we already have. So just giving this new idea, and let's say it's PPO implementation. My goodness, I have 10 trajectory how we can optimize the system even further. But let's stay with the publication by the team. So we are back now here to S3, and they tell us here, the authors, hey, we have 3 main takeaways. And as I told you, hey, how is it now performing against an end-to-end optimization? And this is amazing, and this is really great because they tell us the searcher-only agent is better than the end-to-end optimization for a RAG. I did not expect that system to be true. So they tell us S3 consistently outperforms the search R1 on search quality, revealing that most of the performance gain in RAG system stem here from improving the search capability instead of aligning here the generation outputs. They tell us here the searcher-only training enables also a domain transfer functionality, plus the reward choice itself directly shapes here the search quality. Seems, yes, of course, but think about this for a second. Eh? So using semantically or human preference aligned metric like here, whatever, you have an accuracy function, encourages here the search policy to retrieve substantially helpful documents rather than just optimizing here for some brittle string overlap in your documents. And you know, at the end, this is the conclusion by the authors. We give here the scene here to the authors, and they tell us our results show that a targeted search policy learning yields substantial gains in both the efficiency and the generalization, offering here a scalable path for improving here the RAG system even further. You noticed here, it's about the search policy learning, about the interaction with the search engine. And if we talk about search engine, comes to mind Google. So Google is here in a perfect place to have here further optimized RAG system, because if it's really true what the authors here of this S3 publication tell us, it is not about a general optimization, but it is really that you have the perfect search engine that brings you back the data that you need for the user query. And that the search policy learning is the most important thing here in the complete interconnected system. Then I think OpenAI, who does not have maybe a search engine that is as powerful as Google's, Google is a real great place here. Talking about Google, I found here IO25 quite disappointing because they were talking about products, about new offering to their client. There was not a lot about real hardcore research on AI. But as you see, yeah, for research here on AI, you have to come to my channel. And Google AI was more about product placement and new innovation that they wanted to introduce here to the broader public. Now, I told you that there are quite a lot of RAG is really exploding here in the last days, and I want to give you here a feeling. So this is here May 21st, and we have here for Chinese University of Hong Kong and Tencent, RAG or fine-tuning. You know, the age-old question here, comparative studies on LCM-based code completion. Now, in industrial, where is your retrieval augmented generation? What should you do? Should you rely here for your code optimization on a RAG system, or should you go and say, hey, I have here my training data and I do a fine-tuning on my LLM or on my code generator because this is more efficient. I do not trust RAG to find here really the perfect code for my query because maybe RAG does not understand exactly what code sequence I need. Then, same day, we have here National University of Singapore, Peking University, and Tsinghua University, implicit knowledge extraction attack on RAG systems through benign queries. We have here, what I like here is the shortcut IKEA. I love this. It's about knowledge extraction on RAG system, and they give you here some great ideas. Also, May 21st, here, Peking University, they have here scalable defense. You see, it's a lot about cybersecurity against in the wild jailbreaking attacks here with safety context retrieval, especially for RAG techniques. Really interested if you're into cyber technology. Or same day, May 21st, we have here Renmin University of China and Beijing Academy of Artificial Intelligence, single LLM, multiple roles, unified retrieval augmented generation framework using role-specific token optimization within the handling of subtask within the RAG process itself. Real, absolutely fascinating here. They propose a role RAG system for a unified RAG framework to achieve efficient multitask processing through role-specific token optimization. Have a look at this. This is really a study I selected for you. I really recommend that you have a look. Or if you're really now, this is now hardcore for, if you want, May 21st, 2025, now for, if you want, hardware design task. Yeah, this is it. So we have here what we're working with a graph retrieval augmented generation, so with a graph RAG system, but we are working here on hardware optimization and hardware description, language generation, and language debugging functionalities here. So also some brand new ideas with some integrated RAG optimization here in the relevant fragments, high quality, whatever. And if you think this was a particular day, no, the day before this, so yesterday for me, so May 20th, we had also here the semantic document layout analysis for textual and visual RAG system retrieval augmented generation from NEC Corporation, or you go here with Alan Turing Institute and King's College London, automatic dataset generation for knowledge-intensive question answering task here, where RAG continues to face challenging and handling complex reasoning and logical connection between multiple sources of information, and they want to generate here a dataset to further improve the performance of RAG. Or you go here with Aalborg University and the Technical University of Vienna, hello Vienna, with multilingual dataset for knowledge graph grounded evaluation of LLM hallucinations here. So they work in the interplay of a knowledge graph with a RAG system. Absolutely fascinating. Also real nice Kyoto University, University of Tokyo and Riken. Beyond change, bridging LLMs and knowledge bases in complex question answering. We have here the chain-based knowledge graph RAG methodology that they try to further develop, and they have here a 4-stage framework for predict, decompose, retrieve, and reason. Real nice idea. You have to have a look at this publication if you want to see what's currently happening in RAG. And yeah, it goes on. City University of Hong Kong and Noah's Ark Lab, Huawei in China. And they tell us here process versus outcome reward. The reward function, especially here in our multi-agent RAG systems, are so important if you go with a real outcome reward. But more and more we understand that the process reward has so much more to offer. And they ask here, which is better for an agentic RAG reinforcement learning? So this is really on topic what we talk today. And they have here they develop here a novel method they call here a reason RAG system that automatically construct your high quality data set for evaluation. So beautiful RAG currently is exploding. Have a look at this. RAG in the classical sense for, I don't know, 1 or 2 years, it's not there anymore. We've moved here completely to agentic system. But RAG is still in development, under development. We have brand new ideas. We completely have a redesign of RAG here, and the performance increases. Amazing. Next one is here. Australia, yeah, this is what I wanted to show you. University of New South Wales, Sydney, Australia. Divide per question, conquer by agent, a split RAG. This is what I showed you at the very beginning of my video with a question-driven graph partitioning here, a split RAG, multi-agent RAG framework. So absolutely fascinating to create here semantic partitioning of link information with a type specialist knowledge base. But I think, I hope you got the idea. RAG currently is having a huge revival. We have so many brand new ideas. I think everything started more or less with DeepSeek R1. This was such an important model, such an important paper. It showed us new development trajectories here for RAG. RAG was almost dead before DeepSeek R1. And now I can tell you, RAG, absolutely amazing. Have a look at this for yourself. RAG explained. I hope if you are a newcomer to RAG and you just want to have an idea where's RAG today, I hope you enjoyed it. You had a little bit of fun. And if you enjoy this kind of videos, hey, why not subscribe? And I'll see you in my next one.